In the cartoon world, characters like Wile E. Coyote can start and stop instantly. But in the real world, it takes a moment for an object to start moving or to stop. We can simulate that motion with the sine function. The sine function is found on the operator's palette of the snap commands. You just use the drop-down menu to select sine. And then if I want to know what the sine of 30 degrees is, I just click that and it tells me it's 0.49999. So this is not going to be very useful for moving the turtle. I need increments of at least 1 and ideally more. So if I set the turtle on its y-axis to 50, I'll get a fair amount of movement. If I set the y-axis to 0.49, that's not even going to be half a step. So what I really need to do is multiply the sine value to amplify it or scale it up. And I can do that with the multiply operator. I just drop this in here and multiply it by 100. And then I get a number like 49, which is going to give me more movement. And as long as I'm doing this, why not have a nice whole number rounded up to 50? So I've actually created a procedure that will do that for me. The scale sine function outputs the rounded value of sine of degrees multiplied by 100. So if I say scale, give me the scale sine, it gives me 50 or 100. And I can use that to move the turtle. So if I set the sine to 0, the scale sine value of 0 is 0. 15 degrees is going to be about 26. So the turtle will go to 26. This is going to be a little bit easier to see with a loop where I walk through about a dozen of the values. And I've created a variable called degrees, which I'm going to start out initially setting to 0. And then I'll walk through the degrees little by little, changing a few degrees after each turn through the loop. So I'm going to change about 15 degrees each time. Now, this is going to be a little bit easier to see if I put in a small wait. Let's say wait half a second between each movement of the turtle. Now let's see what happens. I said set degrees, and I really need to say change degrees by 15. All right, let's try this. And now we can kind of see that it's moving in smaller steps toward the top and bigger steps as it falls back toward the bottom. I can make this a little clearer by drawing a mark. The draw mark procedure that I created just puts the pin down, moves the turtle over, and then moves it back. So if I say draw mark, it draws a mark wherever the turtle is. So now I can see that the turtle movement is not quite as far as it gets to the top. And then it accelerates or moves in bigger jumps as it falls back. That's very characteristic of the sine function. If I say work my way through a few more degrees of the compass, you can see that this characteristic. And let's put the whole thing in a loop, just so that we can watch it several times and get a feel for it. Here we go. And you can see it moving up and down, slowing up as it reaches the top, and then as it falls through the middle, moving in bigger jumps. Let's clear the screen and And I'd like to move the turtle kind of toward the middle of the screen. And let's take these commands and move the turtle over just a smidge after each turn through the loop. So I can do that by changing x by 10 each time through the loop. So let's see what happens if I do that. You can kind of see that it's making, well, let's stop and bring the turtle back. I can do that with go to XY, and I've actually created a procedure to reposition the turtle and move it over to the left side of the screen. So let's use that. That's going to be a big help. And now let's put the pin down before we start out and do this again. And we get this, looks like it could be a sine wave, although it's a little bit jaggedy. However, if I combine the x and the y movement, then I probably are going to get something that's a little bit smoother. So I'm going to pull out this movement on the y-axis, and on the x-axis I'm going to take the x position and add 10 each movement, each time through the loop. And if I do that and put that into the y-coordinate position, let's clear the screen, reposition the turtle, and try this. We now get a very characteristic sine wave. We'll do more with this in the next module.